Alright, grade 9s. So it's really important that you understand that in mathematics, these formulas don't just come out of thin air. We can notice where the formula comes from by noticing certain patterns that happen when we're doing the long way around. So for example A, I'm going to do this in the longer way to start off with, but we're going to notice some patterns that start to happen. So what happens in our first year? Well, Nicholas started off with 5,000 Rand, and I'm just going to omit the R now so we can focus on the numbers. And what happened, and watch how I write this now, is, well, he had his 5,000 Rand, but then he earned interest. So we worked out the amount of interest he earned for that year, 8% of 5,000 Rand. Well, that means we could multiply 5,000 by 0,08. So if we go and do this here, we're going to get the total amount of money he has after 1 year. But we're not actually interested in that number right now. We want to start to notice some patterns that happen. So in the second year, what happened? Well, we've still got the 5,000 he began with, but this amount represents the amount of interest he earned in 1 year. So in 2 years, we're going to have 2 lots of this interest. So we can take 5,000 Rand and the interest for 1 year. But if it's simple interest, it's going to be exactly the same amount for the second year. In the third year, we start off with 5,000 Rand, and now we're going to have 3 lots of that interest. And then finally, in the fourth year, his original amount of money, 5,000, and he has 4 lots of interest. Start to notice when it comes to having a formula, what's changing and what's staying the same. Every year we have 5,000 Rand as fixed, and we always have 5,000 times the interest. But what changes every year? Well, it's how many lots of that interest I have. So there's a connection here between how many years it is and how many lots of interest we make. That should make sense to you. So in the nth year, in year n, what would we have? Well, we'd have 5,000 Rand plus 5,000 Rand times 8%, and we would have n lots of that interest. Now that's getting closer to something, but that still doesn't look like our formula. So now we need to remind ourselves of another mathematical idea that we've encountered already. If I look here, in each one of these things, we've got 2 algebraic terms. This plus separates our 2 terms in each case. And what do we notice with those 2 terms is that we've got a common factor of 5,000 Rand. So what can we do with that common factor? So if I wrote my common factor down, I'm dividing 5,000 out of each term. What is going to be here is the 1. You should have been wondering, where does this 1 come from? Think about it, 5,000 times 1, well, that's my 5,000. And then my second term is going to be, well, I'd take this term and we divide it by 5,000. So in the first one here, we're just going to have 0,08. Now, if you look at this here, this should remind you of saying, well, 5,000 times 108%. So that 1, you can think of it like being 100%. Right, what happens in our second one here? When we take 5,000, 1 plus 0,08, but now we also have times 2. Let's fill in the rest. So what is it going to look like in the nth year, in any year? Well, we see that we always have 5,000 as a common factor. So 5,000 is my common factor. What's going to left? Well, if I divide 5,000 by 5,000, I've got 1. And if I divide this term by 5,000, I've got 0,08 times n. Can we see where this formula comes from? What does the 5,000 represent? Well, that was my initial investment, P. We're always going to be able to take a common factor of the principal value out. So we're always going to have a 1. The 0,08, well, that was my interest rate, which now we use as the letter I. And then we're always going to see that we add n lots of that interest. And all of this will give me my total accumulated or accrued value. So I hope that was interesting. You'll never have to be able to prove it to me, but you should always wonder to yourself, where do these formulas come from?